Hello everybody, welcome to our 5.1 concept video. And now that we're in chapter 5, we're still going to be talking about integration, but now that we're done with chapter 4 and we've learned how to integrate functions, now that we're in chapter 5, we get to talk about ways that we actually use this integration. Different contexts or different applications that actually use integration to perform calculations and to get meaningful results. And the first thing we're going to talk about is this idea of consumer or producer surplus. It's a metric that measures how satisfied a consumer is or a producer is with a specific product. And the way this works, we're going to start by focusing on consumer surplus because consumer surplus is related to a demand curve. Now, we've talked about demand curves before. We talked about these when we talked about elasticity of demand. We've talked about demand curves, so just a couple of reminders with demand curves. A demand curve relates the price of a product with the quantity you'll be able to sell. And something to remember about a demand curve is that a demand curve will always have a negative slope. Why? Because if you increase the price of your product, you won't be able to sell as many. But if you want to sell more products, you have to decrease the price. So with that in mind, let's draw a graph of just an arbitrary demand curve. Notice I'm going to give it a negative slope. It's a decreasing function, and I'm going to let my y-axis be price and my x-axis be quantity. I think this is actually reversed from how we talked about it back in chapter 2, but these two variables are interchangeable of which one's independent, which one's dependent. And so in this case, we're going to let quantity be my independent variable and price be my dependent variable. Well, let's say I pick a specific quantity Q. And I say, I really want to sell this many products. Well, the demand curve is going to tell me, oh, okay, that means I need to set the price at this value right here. That's what the demand curve helps me do. It helps me find a corresponding price for that specific quantity that I want to sell. But where we're going to relate this to integration is we're going to talk about what happens when I multiply these two things. What happens if I do P times Q? Well, price times quantity, that's how I calculate revenue. But graphically, what did I just do? This distance right here is Q, and this distance going up is P. So what I just did is I found the area of this rectangle right here. That area represents my revenue. So pretty interesting that I have now this area under my graph that is actually meaningful. It has meaning in this certain context. But that's not the true area under the curve. I'm leaving out this area right here. Does this area actually have meaning? Well, it turns out it does. This area is what I consider the consumer surplus. Why? Remember, the demand equation represents what the consumer is willing to pay. But this rectangle that we just found represents what the consumers actually paid. So, to summarize this using mathematics, the area under the curve, I can notate using a definite integral, right? The definite integral represents the exact area under the curve. Like we just said, this represents the amount that consumers are willing to pay, emphasis on willing. And the rectangle, which was just P times Q, price times quantity, represented the amount that consumers actually paid or actually pay. Emphasis on what they actually are doing. Which one's a bigger area? The actual area under the curve is bigger, meaning that consumers are paying less than what they're willing to pay. And that's a good thing because that is what creates customer satisfaction. They feel like they're getting a good deal. By using integration, that actually becomes measurable. The bigger the leftover area, the more satisfied customers are going to feel. The smaller the leftover area, the less satisfied they're going to feel. So we can measure that just by finding the area under the curve minus that rectangle value. And this gives me what's called consumer surplus. Well, it turns out that there's a similar calculation for producers, the people that are actually producing the product. So I also have what's called a supply function, S for supply, that measures what producers are willing to do based off specific price. So slightly different, where demand functions is all about the consumer, a supply function is all about the supplier or the producer. And the big difference here is a supply function will always have a positive slope. And this took me a while to wrap my head around, but the reason why is because if you're going to charge more for your product, then suppliers are going to be much more on board with actually producing the product if you're going to be making more money off of it. If you're not going to be charging as much, they're not going to be as willing to produce as many products. It's not worth their time if they're not going to be making a lot of money on it. But if you charge a higher price, then they're willing to make more because they'll make more money. So that's why supply functions always have a positive slope. So if we look at a supply function then, with a positive slope, I can do the same thing that I did with my demand function, where I can pick a specific quantity and say, okay, let's say I want to produce this many. I want to produce this many products. I can follow that demand curve up to my function, and that gives me the price that I should set it at. Now, of course, this is only in regards to the supplier. So it's the price that I should set at in order to make my supplier happy, in order to actually be able to use that supplier. Once again, I can find P times Q, and it'll give me the same thing. It'll give me my revenue based off of that quantity and that price. But in this case, that area is bigger than the area under the curve, right? The area under the curve is this area right here. And in this case, that's a good thing. Why? Because now the actual revenue is bigger than the revenue the producer is willing to make. So the same kind of thing applies with the supply function, where the area under the supply function represents the revenue the supplier or the producer is willing to make, but P times Q is what they're actually making. And once again, we want the actual revenue to be bigger than the revenue they're willing to make so that the supplier feels satisfied. The bigger this leftover area, the more satisfied your supplier is going to feel, because it feels like a bigger profit margin for them because they're making more than they thought they were going to make. So we once again now have a metric for this using integration, where I can calculate it and to find what's called the producer surplus. But in this case, because the actual revenue is bigger, I start with that value and I subtract the actual area under the curve to find producer surplus. So both of these represent metrics to measure consumer satisfaction and supplier satisfaction. This begs the question, what if I have a situation where I have both? What if I have a demand function and a supply function? I know how my demand's going to change when I mess around with the price, but I also know how my supply is going to change if I mess with the price. Well, your mind's probably already drawn to it, but there should be a point where these two lines cross. And this point where the lines cross is called my equilibrium point. And this equilibrium point represents the optimal price or the optimal quantity you should try to sell in order to not only make your consumers happy, but also make your suppliers happy. This equilibrium point will optimize the consumer and producer surplus. So it ends up being a very important kind of concept. If we can find where those two functions cross, then we can find how to optimize our consumer and producer surplus. So how do we find that? Well, if we have both equations, you can calculate where they cross by setting them equal to each other. And that's how you can solve for your equilibrium point. Okay, so that's the concept behind producer and consumer surplus. Go ahead and start on the homework. Try a few of the problems out. They're actually all the same. All of them have the same format. It'll give you a demand equation, a supply function, and it'll have you find the equilibrium point and then calculate both the consumer surplus and the producer surplus. So go ahead and try them out. And if you get stuck, go ahead and check out my examples video. Good luck, and I'll see you in the next video.